We're going to talk about automotive today, but also wise usage in devices is something that is addressed by the innovation team at Audiokinetic.
Great, and you're the innovation team lead, heading up all of these fascinating special projects at Audiokinetic, one of which is Wise Automotive.
Correct. And basically, today's presentation is a little bit different from the rest of the presentation in this event, in the sense that mainly what we want to do with the little time that we have is plant the idea that the same tool set, the Wise tool, can be used differently to serve different interactive audio requirements that exist in applications outside of gaming. And today we're going to use automotive kind of as an example, as a rethinking of how Wise can enable applications on that side of things.
I know, like Wise in your car. It's the craziest thing, but also not that crazy because when we think about all of the interactions that we have in a vehicle across the different ways that we interact today, it seems like kind of a no brainer.
Yeah, I mean, there's a in my presentation, I will discuss the model of interactivity, and we see that there are some clear parallels between how we interact with game audio and how we can interact with different systems in a car, and what are the different needs there in automotive for interactive audio.
Awesome. Well, I'm ready to hand the presentation off to you. Take it away.
Thank you. All right. So basically, the agenda today, I want to have look at what's similar, but also what's different for doing game audio, which all of you are familiar with, and how does this translate into the automotive audio, the kind of requirements and the kind of interactions that are required there. So this is a vast field of application, and to make it more concrete and a bit more fun as well, we want to show a quick demonstration video where we'll show how we can have audio branded engine sound generation that's used for pedestrian safety outside the vehicles, mostly electric vehicles. And basically, this is going to be the perfect segue into the second part of the presentation, where we have a special guest from season 3 audio. He's a sound designer. He's going to tell us more about using electric vehicle sound and sharing his experience doing so in Wise as well. So that's going to be the second part of the presentation. So let me dive in immediately. So I want to take it very high level at this point. This presentation is not going to be technical, but basically to show some parallels between the gaming world and the automotive world. So if you look at both ends of this diagram, basically you have the same human interaction triggering, in the case of a game, through the controller and the game systems. In the end, that results in Wise runtime events and some sound playback. So that's the part that you very well know. Let's look at what this means in the automotive world. So in the automotive world, you have a driver that's perhaps stepping on a gas pedal. This information is transferred to vehicle network systems. We often call those CAN buses. It gets to one of the many onboard computing capabilities. Could be the infotainment platform, where Wise is embedded, and basically can trigger sound feedback for the driver. It could be also other systems in a car. So not necessarily the driver directly triggering things, but it could be things like radar systems, LiDAR cameras. Those are very common in modern vehicles, triggering a collision warning system, for example. So there's a lot of different sound requirements within the vehicle, and we're going to try to look at that later in the presentation. So another approach where I want to show a fundamental difference between game audio and automotive audio is that in a game, it's usually a foreground application, and basically there's a one-to-one relationship between the game and the Wwise runtime, and the Wwise runtime itself is embedded in the application package itself. Things are very different for the automotive world, where what we do with the Wwise runtime there, it's packaged more as a service or as a platform extension that can service a multitude of different applications. It could be media playback, safety kind of application. It could be augmenting navigation with some auditory cues that are useful for the driver. But all of those applications essentially run in the background, and Wwise needs to be available to all of these applications at all times to service the different interactive audio requirements that they might have. Another angle in which I want to look at those differences and similarities between the gaming world and the automotive world is that, well, so in a gaming world using middleware, there's the sound designer using the Wwise authoring, creating data package sound banks that are consumed by the runtime component. As you know, the sound integrator hooks the triggers, the different events and RTPCs. And because those two are usually in the same company, they can communicate easily. Ideally, this leads to a great sounding game. But that's really far from the situation in the automotive industry. So you have car manufacturers that are deeply interested in the sound design aspects. They have sound designer on staff. And basically, they want to control the sound experiences and the audio signature and everything like that. But the integrators usually in an external company, some kind of supplier, it's a really deep and complex supply chain in automotive. And they communicate through requirements and SOWs, and all of these things, as you probably guess, are very inefficient, costly, and long, and in our view, doesn't lead to the best possible sound experience in your car. So what we see in the automotive industry is that this separation of roles that middleware like Wwise provides with a data-driven approach and event abstractions and things like that is even more important because it completely changes the game. So you can have the car manufacturer designers communicate just basically the Wwise sync IDs, the events and the RTPC names and things like that are still integrated by the audio integrator in an external company. But once that's done, the OEMs are now in full control of the experimentation, changing the sound, the behaviors, all of that. So it's very empowering for the car manufacturers to have a data-driven approach in the loop. And basically, this brings a lot of efficiency and cost savings. Going down, so this presentation is kind of a funnel where we go more and more specifically into the automotive features. And really, there's two class of sound requirements for automotive. The first one is grouped under interactive sound generation. So that's where you have like engine, vehicle sounds, things like that. This is the part that we'll focus on in the second part of this presentation with Carlos. So I'm going to skip here. But you have all sorts of touchscreen interaction and overall HMI feedback, and sometimes there's no screen. So the only way to interact with the user is through sound. And this is where features that you know and love, like switch containers, for example, can be used to create different audio profiles or audio themes. So perhaps when I get into my car, uh, different key fob, car remembers my profile setting, and I get a completely different sounding experience HMI wise than my wife, for example. Another very critical feature of interactive audio for automotive is with respect to sound spatialization. So all of the safety warnings in the car, for example, the camera can detect that there's an object, perhaps even in my blind spot, so I don't know about uh, uh, that object. And basically, sound can be used, and sound spatialization specifically, in particular, if you have uh, headrest speakers in the driver and binaural capabilities, then I can really focus the driver and let them be aware that there is a car in their blind spot, for example, as they're trying to overtake. So all the idea of sound spatialization plays really a vital role in automotive audio applications. The second class of requirements for automotive audio is more with respect to audio management. And that's where we need to handle all of different concurrent streams going on in the car at the same time. So it can be with respect to routing. For example, we have media playback or incoming calls, say, hands-free, and the calls for my wife, swipe gesture to the passenger seat. The audio is transferred over using aux, listener assignments, and whatnot, and Wwise, and all of this audio is dynamically flowing from different zones within the vehicle. There's all the idea of prioritizing these streams with things like volume ducking. So I have the navigation prompt. I want to use features like auto ducking or perhaps side chaining so that I can reduce the media playback. This is again falls under audio management category. And perhaps one last one I want to mention is a feature of the authoring, but it's extremely useful in automotive, is the fact that you can use custom platforms to create as many platforms variation as you need. And the reason that this is useful is that car manufacturers have a lot of different models that are very similar, but sometimes different through their audio audio upgrade, for example. There can be some different geography with different requirements. So this creates a lot of different configurations to support, and using custom platform and platform unlinking to tune some specific variations allowed to keep a single Wwise project managing all of these for the common elements while being able to tune the specific variations. So I want to make it more concrete. So next we'll have a quick video demonstration about engine sound generation for pedestrian safety. This is called AVAS. Carlos is going to discuss that in more details. But first, we would like to see a video where it becomes clear to me that same car, same situation, but just by changing the sound design, you completely change the sound identity. And so Damien is going to play the video. That's the end of my part. And after the video, we'll have Carlos Rodriguez of Season 3. He's the creator of the sounds you're going to hear in the video. And he's going to discuss more about the requirements in creating electric vehicle sounds and his experience doing so in in Wise. So, yeah, thank you.
Hello, everyone. Mm, s- okay, next slide, please, François. Yeah, sure. So my name is Carlos. I worked together with François to create the video that you just said. These AVAS examples for 3 different sound profiles, and I'm going to tell you a little bit about my experience working with Wise and the whole experience of designing sound for an electric vehicle. And first, we need to know what is AVAS. It's called Acoustic Vehicle Alerting System, and it's an external sound that is played by outside the speakers, placed usually at the front, at the back, and in the front and the back of the car, and is mostly defined by law in different countries since 2019. So there are parameters that are fixed, and is 0.8% of pitch shifting per kilometer. Is usually up to 32 kilometers an hour. The frequency band that it needs to play on is defined as well. It must be a continuous sound when driving forward, and we cannot use nature sound or sounds that could be recognized as nature sounds. So we cannot use rain or wind because it needs to be identified as a vehicle. Mm, this is one part of the sound identity for electric vehicles, but it's comprised of AVAS, the UI UX sound constellation, and another sound that we'll talk later. But what are the characteristics that a sound identity for a car must have or should have? I would say it needs to be safe for the pedestrians, the visually impaired, cyclist, and the driver, of course, is the main priority. Then it needs to be useful. It needs to convey the information, and it's used daily, so it needs to be something that is not annoying and that we can live with it daily. So it needs to be something that is really useful. Then it needs to be respectful with the acoustic ecology of the cities. If we are removing combustion engines that are a lot noisier, we cannot go and make a lot of noise with our new electric vehicles. It needs to be respectful with that as well. It needs to be cohesive. The sound gestures and the sound signature needs to be tagged together, and in the end, it needs to be branded. It has to be in line with the manufacturer's vision. It has to translate very well to other models and equipment tiers. And the most important, it needs to be recognizable and memorable. You're on the street and you might be able to identify, okay, this is such brand, this is such model, this is the goal. That's the theory. How we do develop as an identity from start to the end. As a sound designer, as a branding expert in this case. So there is a brand, there's a maker of cars that has some values, has a message, has a history, a vision, and a mission. And they release or they are creating a new vehicle model that has some characteristics and qualities. Is it going to be a very powerful car? Is it going to be a family van? Is it going to be a SUV? There is some characteristics that the model is going to have. And then there's a target audience for that vehicle. The market, is it going to be only for the Asian market? Is it going to be for the North American market? What is the segment? Is it going to be wealthy suburban? mm, Wealthy suburban? Is it going to be city, young city people living in small cities? What is the target audience? With these three ideas, we are able, as sound designers, to conceive a sound identity core. So with through different workshops that we do with the brand, we establish certain sounds that we can correlate to these characteristics, and we create a sound identity core. Then we look at the user journey. How is the user going to interact with his or her new car? Is it going to be mostly driven from and to the mall? Are you going to take the kids to school? Is it a very powerful car that you're going to take into the racetrack? Maybe. So based on this user journey, we model this identity and we apply it into different applications that a car can have. That's ABAS, the external sound we just talked, that's mandatory. Then we have the UX, UI sound constellation. And what that is all of the sounds that create feedback for the driver in an active or a passive way. That's the warning, courtesy sounds like welcome, goodbye, lock, unlock. And driving modes, of course. Are we driving in eco? Are we driving in sport? Are we driving in comfort mode? All of this needs to be represented in the sound of the car. There is also a mobile app with all cars that has to have the same sound identity. And there are equipment lines. So if you have a GTR line from a car, it needs to be more aggressive than a normal car because it's going to be a different kind of segment. This is the theory. How did we do it for what you just heard in the video? We had three profiles: urban, comfort, and performance. The first one, we envisioned a compact EV for the Asian market. The sound identity focus was safety. And in this car, we took as a reference the Honda E. And this car is done with organic natural materials. So we say, okay, for this sound identity, we're going to use organic instruments. And we use flute, piano, strings, this kind of pads, and apply them to the ABAS and the UX, UI sounds. For the comfort one, we were thinking about a small SUV for the European market because it's very popular at the moment. And buyers in Europe are young. They are looking for smart features. They are very conscious about sustainability. So we're going to focus about this digital acoustic ecology. And we use for that warm, digital, and analog synths. And lastly, the last one for performance, we envision a luxury sedan for the North American market, making long drives at high speed, has a lot of horsepower, has a lot of range, a lot of megawatts. But where do megawatts come from? It's not about gas anymore, it's about electricity. And where does electricity come from? From turbines. So we use a lot of turbines from aerogenerators, from hydraulic turbines as well, electric guitars, square waves, everything that made it sound very gritty and very powerful. So this is the actual thing, the actual praxis of how did we do the sounds, how do we apply this theory. Then we needed to work with Wwise. How does Wwise and the vehicle understand each other? It's the car is another stream of information. So we use three streams or three parameters from the car. That would be speed, pedal position, and load. And each of them we mapped to an RTPC in Wwise. Speed would affect the pitch. Pedal position, how much are we accelerating or not? Because we can be very fast in going down, but we are not accelerating too much. So it would trigger different layers that we created in Wwise. Or the load would apply different volume to the different layers. There is also all of the one-shot triggers for the sound constellation. Then all notification sounds, like it could be a state of charge, dead angle warning, another warning sounds. Like you are falling asleep, there is always a warning sound when you're falling asleep in the car because there is driver monitoring. There are also feedback sounds, active feedback sounds. When you lock and unlock the car, when you change driving state from park to drive to neutral, when you change driving mode, so you put it in sport mode, you need to have feedback for an action that you just did. And then there are experience sounds, like that they round up the experience of the car, the user experience of the car, like welcome, goodbye, all of these sounds that are courtesy sounds, so to say. And now the final Ava sound design in Wise. How did we do it? You see a screenshot of the project, and what we did is layering with a lot of different materials. So we have fundamental waves like sine waves and square waves that create harmonic parcels, or what is called in the combustion engine world called orders. So that's the harmonics, the physics of the actual engine will create vibrations that are like partials in the harmonic scale. And this is the same that happens when you combine sine and square waves. So we'll create this distortion and harmony at the same time, and we will get this similarity to how we identify a car, a combustion engine car, and translate it into the electric world. Then we use a lot of seamless loops because that functioning wise works very, very well. So we use our loops imported from the DAW that we create from the sound signature. So we say in the first example, for example, we used flutes, strings, and piano to create that loop, and we imported that into a seamless loop. Then we have the layering because we don't want to have it very static. So based on the pedal position, we will trigger um, different layers with different volumes. And in the end, the car is a live thing. So it needs to feel alive and have a lot of dynamism. That's why with LFOs, we can change the sound, and we can also add sweeteners, what we call sweeteners, that will be based on a specific scenario of driving. We will add a special one shot when, for example, you're going very fast and you make a stop and you floor it again. We would add a special sonic boom for that time, or we would add especially created sounds for the launch mode. The electric vehicles have a lot of torque, so when we launch it from 0 to 60 to make it in under 2 seconds, it's going to be a very powerful experience. So we need to add some experience to that as well. What does this mean for you, this world, for sound designers? There's a lot of opportunities because the game sound designer skills transfer very well to the automotive world because you're bringing a lot of innovation. You're bringing a creative workflow into an engineering environment, and you are able to work as sound designers way faster than the engineers. That means the turnover that you can have with different designs and try it out and test it is going to be much faster, and everyone is going to be very satisfied. And it's a multidisciplinary world, as is game audio, because it's sound design in one part, of course, but it's also user experience. There's also safety. It's very important for marketing as well, because in some of the more exotic cars, sound is going to be a key point for selling, for marketing. But what I want you to take away from this whole experience is like electric vehicles and design is still a blank slate, and there's a lot to be said, and there's a lot to experiment, and this has just started. And I invite you all to look into it because it's a very interesting world. And I hope I see you later on Discord and tell me how will you make our world sound like in the future. Thank you.
Carlos, awesome. So great to get your perspective from out on the edge, helping to define the sounds of these electric vehicles. And the video is up on our YouTube channel if you want to revisit some of those sounds. And again, I thought the way you broke down the different considerations for, market and, use cases across the different techniques that you used was really fascinating, and great to have that experience shared with wise artists and authors out there who, as you have invited them to imagine this future of automotive with us. Again, thank you for sharing your perspective on that.
Thank you for inviting me to tell you all of this. Thank you.
Awesome. Cool.